So you go golfing and use a bright orange ball. Why? So you can see it better. But this bright orange ball actually has some features besides just being orange. You don't usually golf on orange grass that help you see it better, because the sun puts out all kinds of different colors of light, and this golf ball reflects orange. But it's also a fluorescent golf ball. And fluorescence is an interesting little term. It actually describes things that absorb light of one color and send out a light of another color. For instance, this orange ball, you may not know it, is absorbing ultraviolet light, sometimes called black light, light that we can't normally see because it's a little bluer than blue. All right? And so it absorbs that and re-emits it as orange. So it's a little hard to see against my shirt, the golf ball and my shirt. But if I turn on a black light, you'll see that my shirt does not fluoresce, whereas the golf ball does. Now you can see the golf ball is orange and my shirt is not so orange. That's because the golf ball is taking advantage of the ultraviolet light that you can't see very well and the camera's not picking up, and changing it into orange light and re-emitting it as orange light. So how does fluorescence happen? Well, you need a molecule and you need a piece of light, a photon of light. Okay? That photon of light comes in and hits the molecule and is absorbed by that molecule, causing that molecule to gain some energy. And it turns out it's easier to absorb higher energies of light, like blues and purples and things. And so black light is actually ultraviolet light, okay? And that's easier to absorb. So most things use black light to do their fluorescence. All right? And so when you have this molecule and it has extra energy and it's kind of moving around, well, then it moves around and wiggling stuff, and then it re-emits that energy, okay, as light, but it keeps some of the energy to itself, so the light it re-emits is now lower in energy. So it can come in as ultraviolet and go out as orange, like in our golf ball example. Now, fluorescence is something that can actually occur naturally and is sometimes used to identify rocks. We've got 4 rocks here that look like common, everyday kind of rocks you might find on the ground. But when you shine black light on them, they turn a really pretty color. You've got this green and the white. This white turns yellow, nice yellow, and a nice blue. So that each one of these rocks is bringing in the ultraviolet light, okay, which is sometimes called black light, and then is re-emitting it as a different color. So you can see that different rocks will re-emit different colors because of the different compounds. So now we can then take the chemicals from naturally occurring rocks, or we could then go out and make our own chemicals that are fluorescent, that take in light of one color and re-emit another, and we can do some fun things with it. For instance, I can write secret little messages. You can't read this very well until I turn on some black light, and you see that you've got several different colors. With the lights out, it's even stronger. So now I have a question for you. If I go disco bowling, where they got the cool black lights and I'm bowling and everything, a lot of times I'll see my sock glowing. Black light on, black light off. Black light on, all right? And so why do my socks glow? Well, that's because detergent companies keep trying to tell you they make white whiter than white. So I have a little bag of detergent here. If I put it on top of the table, you can see that it's glowing. All right, if I shine the black light on it, it's glowing bright white, okay? And detergent has special chemicals in it that fluoresce. What they do is they absorb the light that we cannot see from the sun, okay, the black light, the ultraviolet light, okay, and absorbs that and re-emit it as blue. So that's why these glow under black light. They glow a little bluish white, okay? And when you mix that blue color with your shirt, if you have a white shirt, with time, I'm afraid your white shirt's going to get a little yellow. But if you mix in the yellow that the shirt naturally is, as it tinges towards yellow and gets dirty over time, and add in the blue light that is being reflected or being produced from the fluorescence, your shirt starts to look white. And you get something that's whiter than white. Because real white eventually turns yellow with use. And as long as you got detergent in there mixed up, it helps it glow a little bluish and makes it look white again. Last thing I'm going to talk about is phosphorescence. All right, you know what fluorescence is now. Phosphorescence is sort of the same thing, only it lasts over a longer period of time. These are all 5 pieces of white paper. They look like they're white paper, They're coated, though, with a special substance to give them a bit of color. All right, that glows under black light and makes it look like. So if I turn on the black light, you can see just faintly there little different colors. Each one looks a little different color. And if I turn off the black light, they'll again look kind of, yellowish white. Okay. Phosphorescence is the same thing as fluorescence. You've got a little photon of light coming in, and it hits the molecule, and then it re-emits a different color. All right? But in phosphorescence, what happens is that it stays in the molecule for a longer period of time. So not all of the molecules reflect the light off really quick. Phosphorescence, it can hang around a while, and it'll slowly give off light. Okay? It'll give off one photon, but it'll, it may have a delay in it. And so phosphorescence will absorb light, and then when you turn the lights off, will glow for a while. So let's check this out. We'll start them glowing. We'll turn off the light. We got them all glowing there. And then I'll turn off the black light. You can see that it takes longer for them to decay, particularly the green one stays glowing for a long time. Turn the black light back on, and you see all the pretty colors. We get everything back. And without the black light, they all look the same color. So we've learned about fluorescence today and phosphorescence, which are very close to the same things. And what you're doing is you're taking one color of energy, one color of light, and changing it into another color of light that's lower energy. So until next time, enjoy playing with black lights, but be careful you don't hurt your eyes, and I'll see you next time.